Hello. In this video, we are going to model the simple cubic 110 surface using Lego bricks. Here we see the simple cubic 110 surface modeled as our metal atoms. These are 1 by 1 rectangular bricks, and they are placed on a so-called flat base of tan in this particular case. To make things easier to see, we've removed our paper figure to make it easier to see the underlying arrangement of metal atoms. For the simple cubic 110, we notice that along this particular axis here, going from left to right, there's a distance of 4 studs in between each of the atom bricks. So we have a constant distance between, a translational distance of 4. So this corresponds to the edge length A for the cubic structure. When we had our previous 100 simple cubic structure, in this particular direction we had a distance of 4 units, and we also had a distance of 4 units going in this direction, in the Y direction, up and down. In this particular case, going from left to right is the edge length A, which is 4 units, 4 studs. This distance here we've modeled as 6 units, which is 1.5 A. This is slightly inaccurate in the sense that this particular length for the 110 simple cubic structure should have a length of square root of 2 times A. Here we're using the fact that the square root of 2 has a value of 1.414, which is very close to a value of 1.5. So approximating the unit cell, where we would have a distance of A in this direction and a distance of square root of 2 times A in this direction, is closely modeled by having the length A here and the length of 1.5 A here, while we're using A is equal to 4 for the edge length. Here we have 2 molecules of carbon monoxide adsorbed on adjacent on-top sites for the simple cubic 110 surface. It turns out that simple cubic is not a particular common structure. It is only generally found for the metal polonium. But we can accurately represent the general layout of the structure using the Lego bricks. Here we have the same surface with the same 2 adsorbed carbon monoxide molecules, but now shown from a direct vertical viewpoint. Now we can overlay the paper figure, which gives us some more information about our surface, and we notice that the edge length here is clearly represented as A. So this is the distance that is 4 units on our Lego board, but this is the edge length A for our particular cubic structure. Also reminds us that this particular length here along this edge is most accurately the square root of 2 times A. As a result of that, using trigonometry, we can see that the length going from one atom here to the atom on the corner would actually be the square root of 3 times A. And here we have the surface zoomed in. Now we can look at the adsorption of oxygen atoms onto this particular lattice. The paper figure reminds us, using these solid dark lines, the dimensions of one particular unit cell. And we notice that here, these oxygen atoms are at the on-top positions at every position at the corner of the unit cell. We call this 1 by 1 primitive coverage in Wood's notation. So we would say this is 1 by 1. Here we have yet another example of primitive 1 by 1 coverage, because we're just expanding our coverage over a larger area, but within this particular area we notice that at each of the vertex points we have an absorbed oxygen atom. So that makes this the 1 by 1. So for contrast, let us see what 2 by 2 coverage would entail. Here we have primitive 2 by 2 coverage of oxygen atoms on the simple cubic 110 surface. So notice that we have an oxygen atom here, but we don't have one there. To get to the next oxygen atom, we have to go not 1, but 2 unit cells. So that accounts for the first 2. In the other direction, we don't go 1, we have to go to a second vertex point before we have an adsorbed oxygen atom. So that accounts for the second 2. So that's why we have 2 by 2. And it's primitive because even for this particular setup, we have oxygen atoms at the corners of this sort of large cell, but we don't have anything in the center. And the not having anything in the center is the key point of the primitive. This is now a very similar pattern, but now we've added oxygen adsorbed atoms here and here. So now this is almost as if it's in the center of this 2 by 2 rectangle. This one is in the center of this 2 by 2 rectangle. So that's why we think of it now as centered 2 by 2 and not primitive 2 by 2. I thank you very much for your attention. Have a good one.